In this video, I would like to give you some tips regarding very common mistakes that students make while working on assignment 1. So let's open this business requirements link. This is our elevator project, and I would like to share with you some examples of use case and object diagrams. So let's take a look. First example, the object diagram, is just displaying too few objects. It is not possible to make much progress with this little information, and it's anyone's guess what this GUI means here. So this doesn't look good. Another example of an object diagram, we have the lobby, parking, entrance, floor number, elevator number. But what about simulation scenario, and what about the traffic control system? And where's the visitor object? It just takes us in the wrong direction, I think. Not a very good diagram. An example of a use case diagram. Let's first take a look at the actors. A simulation personnel may be okay, just maybe, but the visitor is just a bad choice. If you read the introduction part of our business requirements document, you will see here that it talks about professional analysis, scientific research, things like stress testing, evaluation of the technical limits of the equipment, personal training, somebody who may be hiring staff, somebody who wants to learn and practice professional skills. I suggest that you keep in mind these questions when deciding who should be your actors. And please do not confuse the visitor object with our actors. The visitor object is a business object in computer memory. How can the visitor be an actor? It's just plain wrong. Also, take a look at some of the use case names. They must be verb phrases, like commands or tasks. So things like GUI, what does it mean here? I don't know. The way you measure the quality of the diagram is if you give this diagram to a team of developers, how can this be helpful to them? Also look at these bubbles over here, open door, closed door, elevator up and down. Is this a service app to control elevators in the building? No, it is not. Open and close door, this may be a method in the elevator class, but not a use case. This sort of reminds us about a set of buttons you see in the elevator control panel. Software abstraction means that we don't have to use every single physical detail about the objects in real life, and we can implement more abstract version of the elevator without each tiny element of the elevator car in our software. Let's move on to the next example. This diagram looks very similar to a set of use cases that looks like a set of buttons in the elevator control panel, like this open door, closed door, up and down. But our application is not about controlling the elevator panel. When we run the simulation, elevators update their positions and they open and close doors as part of the elevator current state. So having a use case for every elevator state is just totally impractical in our case. Also on this diagram, there is not even a single mentioning of the editing or running a simulation scenario. So clearly somebody doesn't understand the basic purpose of the system. And focusing on things such as elevator mechanism is also totally wrong. Let's see the next case. So this is actually an improvement compared to the previous case. The use cases, at least most of them, are verb phrases, so they look better. And I'm not going into any details of the individual use cases, but what about all of these includes? Just look at the number of includes used in this diagram. So this approach with these includes is completely impractical. Include means that it's always part of the use case that we're trying to include. It's a mandatory extension. Here what we have is that if we open scenario editor, we always load the scenario preferences and we always save scenario preferences, which may be not true at all because the user may not want to make any changes. Maybe they open the scenario editor in error. So this approach is completely impractical. What this diagram should be doing is using the extension. So instead of the include, use the extension which goes the other way in the diagram. And extensions represent optional parts of the use case, interruptions or errors or exceptions. So this should definitely use extend instead of include. Another aspect that I don't like here is this microscopic level of use cases. Do you really have a separate screen for setting number of floors and all other individual parameters in a completely separate set of screens with totally separate set of validation rules? It looks like each use case here is just has one input field on the screen. So I don't know if I would enjoy using this kind of system design. One more big disappointment in this diagram is that we have an actor named actor. This is just an indicator that the person never understood the essence of the actor role in the use case diagram, and they never grasped the type of actors that we have in this elevator simulation software. So I think too many problems. Okay, so this here is just getting worse because it was submitted as a use case diagram, but it's not. Is this application about an elevator rider riding the elevator? No. What is shown here looks more like a state diagram of a visitor object being aware of its state while riding the elevator and visiting a floor. Not even remotely relevant to the set of use cases in our system. So, okay, you may ask, what are the use cases in the system? So I think if we jump to the functional overview part of our description, things like edit configuration, create scenario, run simulation, view statistics, I think you're getting the idea. But keep in mind that these are only top-level use cases. There may be such as pause simulation, restart simulation. Maybe there are statistics specific to the elevators and also specific to the visitors in the building, and so on. All of these are examples of use case extensions. Also, if you're running a simulation of normal operations and all of a sudden you have an emergency in the building, you could definitely model this emergency as an extension to the main case scenario of a running simulation. Such extension to one of the use cases may also have an impact on another use case, such as create edit scenario, which may also be getting more complicated in support of the extensions to satisfy the needs of the simulation run. But all of this is totally your choice. Just try reading this business requirement document again to identify all use cases that you want to include in your design and all use case extensions that you think are reasonable to support the system functionality. So this approach, this design is a complete miss. Okay, so just keep in mind that we need to be focusing on this set of functionality, and this is only the top level. So please be sure to identify the necessary use case extensions. Okay, next example, and where do I begin? This is kind of tragic because what kind of feedback can I send back to the student? Imagine if this is given to a team of software developers, some folks may find it offensive. That might result in a hostile workplace environment investigation by HR. Really, what can I say to this person? Please start reading the book and watch the lectures. Okay, let's see what else we have. So here we have a very badly identified actor named computer user. And the diagram has just one single use case accessible by this user just out of the blue. So no configuration, no scenario editing, just straight to run the simulation. But let's try to navigate this diagram. So start simulation includes, notice always includes, load elevator simulator. Okay, so I suppose we may be loading some data. So then in its own turn, it includes, notice always includes, an elevator request. Okay, so that also always includes an elevator stop. and the elevator stop somehow just happens to be an optional case of an emergency stop, because it says here extend. So that's really confusing. But then it also says that the load elevator simulator always includes the emergency stop. So the way it's all modeled with all of these includes is just completely backwards. I would say that maybe emergency stop is an extension of the regular stop. And also remember that instead of using all of these includes, most likely what you would like to use is the extend. And the extend is going the other way. Also, this bubble here, open and close door, I suppose this is open and close the elevator door, is completely meaningless, because what it implies is that somehow this computer user, which will be able to access this use case, will be in charge of opening and closing the doors, which is absolutely meaningless because the elevator object is totally in charge of opening and closing the doors. The user is powerless here, so this is definitely not a use case under no circumstances. Moving on, another example of a really bad actor selection here. But also update table, populate table, reset table. Where did you see this type of vocabulary in our requirement document? It just seems like totally irrelevant, and also kind of strange use of all of these includes in the diagram. If this is a run simulation use case, then instead of including these two, maybe it should be modeled as extensions, not the includes. And you may as well just, if you have this update table, which is made up of populate and reset, you may just have it with all of these includes. You just may have to model it just as one single bubble. This is just strange looking design. Okay, let's see what's next. No comment. If you look closely at the names of these use cases, like select floor, close door, move down, move up, this is a classic mix-up of controlling the physical equipment versus simulating an elevator movement in the building while serving the visitors. If we follow this design, our user interface starting to look like an elevator control panel inside the elevator with a bunch of push buttons for the floors. This is not what we want at all. In our case, the user interface is showing a building elevator simulation where we display moving positions of the elevators in the building. We can make visible how many people are riding the elevators, how many people are visiting a particular floor, but not the elevator control panel. And I'm kind of totally lost in this. This diagram reminds me of a flow chart that pilots use before the aircraft departure, like checklist of actions to hold the door, to close the door, to select the floor, to check whether the floor indicator is lit, and start moving up or down. I'm just really lost here. What I like on this diagram is this abstract set of connecting lines. Looks like a maze. You could use this diagram as a board game to play with your colleagues during lunch. So moving on. The set of actors here may be okay, just maybe. So we have a manager, a researcher, emergency inspector, and so forth. But it's not immediately obvious what the roles of all of these actors are. Nevertheless, again, we have a mixture of physical equipment functions and usable use cases. Create scenario. This is okay. Collect data. Is this a part of scenario that collects statistics during the simulation? It just looks a little weird like this on its own. Run simulator. Potentially okay. Fix elevator. Stop elevator. Test elevator. And so on. What are these things? How do they fit into running a simulation of visitors visiting a building with functioning elevators? This could be something to train the elevator repair crew on how to maintain the physical elevator equipment, but has nothing to do with the business requirements of our system. The connecting lines also causing a little bit of a headache, don't you agree? Okay, next example. What this looks to me like someone is thinking about the user interface window visible to the user and a top-level menu with the typical choices for file, edit, help, and so on. So this is not the way to model the use cases. Imagining a computer screen is the last thing I really need to worry about when developing a set of use cases for a functional specification. I am thinking about business rules and business objects which begin to interact with each other to accomplish a specific task. This set of identifiable tasks is consolidated into a list of use cases. So I don't envision this list of tasks like this complicated hierarchical tree. Rather, for me, it's just a plain list of specific tasks available to our actors. Maybe we could salvage some of these bubbles to reorganize them, but definitely not as complicated as this diagram. So it just needs to be much simpler. A choice of an actor here obviously is totally terrible. And you know, as soon as I see total lack of understanding who are the actors in the system, I know immediately this cannot be a good use case diagram. So what else do we have? On this diagram, again, visitor is not a very good actor in our system. Visitor is a business object in our system. Potentially, there could be hundreds or even thousands of visitor objects in computer memory. So visitors are part of our software, definitely not an actor. Remember, the actor is a user playing a specific role while using the system. It's something outside of the system boundaries, not to be confused by the business object. And it's amazing how many times we're already seeing this attempt to emulate physical equipment operation, like with this opening doors, closing the doors, pushing the buttons, and so forth. So with this kind of design, what are you going to see on the computer screen? The elevator control panel with buttons and lights. So this is totally wrong. I admit there could be a possibility that a separate use case where the person running the simulation could have a dedicated visitor object that may be manually controlled by the user. But even then, I don't think we would have to tell that object to enter the elevator. The object already knows how to use the elevators. Instead, we could tell the visitor object what their next destination should be. Not enter the elevator and not to close the door. This is ridiculous to use as a use case in a simulation software. And my advice would be not to try to make it look like you have 300 different use cases in the system. I would go for up to like 10 or 12 maximum, unless of course you want to design a more complicated system. Oh well. Here the actors are totally absent. Some of the use cases are okay. But look, there's this theft alarm. Could be an extension of the play scenario use case. Something like this, right? That extends the play scenario. But unfortunately here it's just modeled as another button on the elevator control panel. So the elevator data panel is back. People just love the elevator panels, but unfortunately our system has nothing to do with them. I begin to feel sorry for people who want to include the elevator panels in the system. If you really like them, go ahead and create your own application, but not in the system that we're trying to build. Next. This also starts looking familiar. Visitor is not an actor. Move up and down are not the use cases. Power on and power off is something to physically control the equipment, but it's not the task that we're trying to solve. What this appears to be here is a set of business objects. If you look at the visitor, it may be an object and these are the methods, right? So this is just like a class in our software. This is the name of the class visitor, and these are all the methods that this class has internally. Maintenance is another class in this system. Okay, so this is the name of the class maintenance, and these are the methods. And it actually inherits from this class, from the visitor class. The emergency crew here looks like another class inheriting from the visitor, also like this, right? So inheriting from the visitor and adding its own methods. So definitely a mix between the class diagram and the use case diagram. Let's see a few more examples. So this looks promising. Actually, all actors and use cases make sense. Of course, use case extensions are totally missing, so this is not a very good reflection of what we have in our business requirements document. But what is definitely wrong here is that this save changes bubble is included in so many different use cases. The data is definitely saved in different files or database tables. So including this same bubble nearly in every use case on this diagram is just misleading and plain wrong. My other suggestion is, if you notice that so many connector lines cross path, you should ask yourself, what are the common use cases between these two actors? And here we have 1, 2, 3, 4 all together. So we need to decide, maybe there could be a common base actor between these two. So this common base actor that actually is capable of doing all these 4 things, and then these 2 actors could just simply inherit its properties, so the number of these connecting lines can be dramatically reduced. So that one needs a few fixes, but may be used as a starting point for adding the extensions. Well, this is a reasonably looking object diagram. I'm not sure about the entrance. I'm not really sure about its meaning. But we have maybe this building configuration scenario class. We have the building. We have elevators. I would say don't name your objects plural. Just basically say elevator and visitor. Simulation and statistics. So this looks fine. Okay, next. Another reasonably looking object diagram. I think it has all essential objects in the system. Here, this is only a part of a use case diagram. We may agree or disagree about all of the relationships between use case bubbles. Don't take all of this for granted. What I don't like here is the actors all connecting to the same bubble. It may be an indication that perhaps one of these actors should be a base actor, like an analyst maybe, and other actors could be inheriting its functionality, right? So it could be relationships like this between these actors. And then we don't have to add these extra lines because we already have one connecting the base actor with this bubble. So this may be okay. On this diagram, the actors look much better. We have some actors that share the functionality using inheritance here. These 3 are inheriting from this base actor, except I think maybe that this line, this inheriting line, should be going this way. So essentially the idea is this is the base actor, this is the actor that derives from it, and 2 other actors are deriving from this actor. This diagram is actually very specific to somebody's design. In fact, a student who designed this diagram has actually written a lot of Java code to implement the system and made it demoable. Just be aware that this is only half of the actual original use case diagram, so definitely please use your own vision and put together a set of use cases that make sense to you. But here you can see some examples of extensions and includes, so that's the main reason I wanted to share this with you, plus the actor relationships that we already discussed. Okay, If you have already submitted any artifacts and you want to change them and resubmit after watching this video, please go ahead and do it, no penalties. I hope this video helps you to clarify some do's and don'ts in this homework assignment.